Hello and welcome back to Neo Psychology of me, your teacher, Mr. Neo, the channel where I teach online psychology lessons to my wonderful students. Let's get started, shall we? Today we're looking at research methods and we're looking at lesson 26, graphs. I love me a graph. There we go. Starter. Why do we use graphs? What are the point in these graphs? What is the point in them? When is it helpful to look at graphs? Give an example of when you use graphs in the real world, all right? When do we use graphs in the real world? Boris loves a good graph, doesn't he? Right. What are we looking at today? Show comprehension and apply knowledge of presentation and display of quantitative data. And then learning objective 2, identify and analyze distributions, right? We're looking at graphs. Let's graph it up in here. Right, here we go. In today's lesson, we continue our discussion of descriptive statistics, so that's the mean, median, mode, range, and standard deviation, and look at some of the ways in which data can be presented and how it may be distributed. Presentation and display of quantitative data. Remember, quantitative is with numbers and qualitative is with words. So, qualitative data. There are various ways of representing quantitative data. Here are some of the ways we'll be exploring today. None of these should be necessarily new to you. You would have covered these in probably GCSE maths or even maths before that point. So we've got tables, which is quite basic, bar charts, scattergrams or scattergraphs, histograms, and line graphs. Let's have a look at these. Oh, these graphs are getting me excited. Summarizing data in a table. There are various ways of representing data. One of these is in the form of a summary table. It is important to note that when tables appear in the results section of a report, they are not merely raw scores and have been converted to descriptive statistics. So what that means is, think about when you did your piece of research and you were finding out whether people obeyed you, whether you're wearing a mask or not. You wouldn't have simply put participant number 1 did obey, participant number 2 didn't, this person did, that person didn't, that person did, whatever. You would put some sort of means or something. Oh, we found an average of this person in this condition did this, and a mean of this person in this condition did this. Okay? So, it is standard practice to include a summary paragraph beneath the table explaining the results. There isn't one for this one though. So, for example, we might find that, the mean number of words somebody said in our Red Bull condition. So if we were to test how talkative some people was, depending on whether they were put in a condition with Red Bull or whether they were given water to drink in a 5-minute period, we might find the mean number of words was 119 versus in the Red Bull condition versus 96 in a water condition, and the standard deviation was 58.3 versus 35.8. And this is what you might say next to the graph, okay? We can see from the mean values that there were more words spoken on average in the first 5 minutes following the consumption of the energy drink, 119 mean words, than the water drink, 96 mean words. This suggests that drinking an energy drink makes people more talkative than drinking water. What does the standard deviation tell us? SD! The standard deviation is higher in the Red Bull condition, 53.8, suggesting that there was a larger spread of scores than in water group condition, 35.8. This suggests that not all participants were equally affected by the energy drink. In the water group, scores were clustered around the mean to a greater degree. So what this higher standard deviation in the experimental condition of the Red Bull means that in some cases, the Red Bull didn't affect people very much, so they spoke very little. But in other cases, they did talk a lot more, possibly because of the Red Bull. And we said that, look, there's a higher dispersion of results. Whereas in the water condition, it was quite similar. There was a smaller standard deviation. Some people spoke a little bit less, some people spoke a little bit more, but it was all more clustered around the mean. So it had a smaller standard deviation. So the water didn't affect people as much, you might argue. That was tables, okay? That's tables. Easy. You know tables. We've dealt with tables. Let's have a look at bar charts. Love a bar chart. Data can be represented visually using a suitable graphical display, so the difference in mean values can easily be seen. the most suitable graph in this case is a bar graph. Okay, so we do a bar graph. Quite easy to do a bar graph. You do bars. Make sure the bars are separate. Okay, what's one issue of this bar graph? Yeah, the bar graphs are separate, but they haven't labeled the x-axis. They haven't labeled the y-axis. There's no title. I don't know what they're talking about or what this represents. It's just a picture, luckily. Here we go. Bar charts are used when data is divided into categories, otherwise known as discrete data. So discrete data is when the data is in categories. In the example before, the categories are our two conditions. We've got the Red Bull condition, the experimental condition, and the water condition, the control condition. And these occupy the horizontal x-axis. So we can see we've got Red Bull and we've got water. The mean number of words spoken is on the y-axis. There's no title though, but there's always room for improvement. And we can see the frequency or amount of each category is plotted on the vertical y-axis, which is effectively the height of the bar. Bars are separated on a bar chart to denote we are dealing with separate conditions, okay? So that's why you shouldn't have your bars together, okay? Because you're denoting that they're in separate conditions. Where in a histogram, which we're going to find out later, they are connected. And there you go, that's bar charts. Scattergrams or scattergraphs. We came across scattergrams in a previous lesson during our discussion on correlations. That was lesson 23. Unlike the other forms of graph, scattergrams do not depict differences but associations between covariables. Remember, correlation does not equal causation, right? Either of the covariables occupies the x-axis and the y-axis. It doesn't actually matter which axis it goes on. And each point of the graph corresponds to the x and y position of the covariables. So, for example, we've got number of caffeine drinks drunk and level of anxiety. And as we can see here, there's a correlation. We can associate and found that the number of caffeine drinks is positively correlated with the level of anxiety. I can't make a causation though. I can't say caffeine drinks, more caffeine drinks equals high levels of anxiety, because I don't know if that's the case. It might be people with higher anxiety drink more caffeine drinks, or there might be a variable that affects both of them. We don't know, but you can say there's a correlation. Histograms. In a histogram, the bars touch each other, right? Love to touch each other in a histogram, which shows that data is continuous rather than discrete, as in a bar chart, okay? So discrete data means in categories. In continuous data, it means that they are discrete. Sorry, rather than discrete. The x-axis is made up of equal-sized intervals of a single category. For instance, percentage scores in a maths test broken down into intervals. So this is people getting between 0 and 9%, between 10 and 19%, between 20 and 30%, between 30 and 40%, etc. And we can see here the majority of people, or 20 people it looks like, got a score between 80 and 90% on the maths test. Well done, good job. The y-axis represents the frequency or the number of people who scored a certain mark within each interval. If there was a 0 frequency for one of the intervals, the interval remains but without a bar. So we can see nobody got a score of between 0 and 10% or 0 and 9%, but it's still there. Line graphs. Line graphs also represent continuous data and use points connected by lines to show how something changes in value, for instance, over time. Typically, the independent variable, so the one we're manipulating, is plotted on the x-axis, and the dependent variable, the one we're measuring, is on the y-axis. For instance, in an investigation of how the passage of time affects our ability to remember information, the decline in recall would be shown on a continuous line. Okay, so we can see the line is continuous. Okay, amount of recall. So if you recall something within 5 minutes of learning it, you're more likely to recall it, or there's a lot more higher chance of recalling it. Whereas as you see, as time goes on, from 1 hour to 1 day to 2 days to 3 days, the amount of recall decreases. Okay. Question. Give yourself 5 minutes. To be fair, you probably need about 1 minute to answer this. Question. What geographical display would be most appropriate to represent the following bar chart? What geographical display would be most appropriate to represent the following? A bar chart, a scattergram, a histogram, or a line graph? It's not a scattergram, a histogram. I'm not redoing this. I'm not editing. It takes too long. Number 1. The change in a person's body temperature over the course of a day. Okay, think about it. What might be the answer? Number 2. The difference in average annual rainfall between Manchester and Paris. Right, okay, I got the idea. Number 3. The relationship between daily temperature and people's ratings of how happy they are. All right, think about the word relationship there. What might be most appropriate? And number 4, the frequency of people who choose snow as their favorite weather condition, broken down into subcategories of age. Categories. Number 1, have a little think. Write your answer down. 1, 2, 3, and 4. Number 1, I think the change in a person's body temperature would be a line graph. Okay, such as with time as well. Line graph. Good, I was right. Number 2, the difference in average annual rainfall between Manchester and Paris. I think a histogram would be most appropriate here. Or a bar chart. Damn. Yes, a bar chart. Yeah, no, that does make more sense. Number 3, the relationship between daily temperature and people's ratings of how they are. A scattergram. And the frequency of people who chose snow as their favorite weather condition, broken down into subcategories of age. A histogram. There we go. Did you do better than me? I hope so. Right. Again, here's another question. I'm going to give you 2 minutes. Know your graphs. For each of the following graphs, A, identify the type of graph, and B, state what we can conclude from the graph. There may be more than one conclusion to be drawn. So, let's start with this one. Number 1, A, identify the type of graph. Right, what graph is that? Well, it looks like a scattergram to me. Well, I'm not going to tell you. Well, I have, but oh well. And B, state what we can conclude from the graph. There may be more than one conclusion to be drawn. Okay. We can see age in years. As age in years goes up, the score out of 20 on a GK test, or general knowledge test, shows to have potentially gone up, but there's a positive correlation. The relationship between age and score on general knowledge test. As you get older, the higher general knowledge is, I reckon, is what I would say. Second one. Identify the type of graph. What type of graph is that? Are the bars connected? No, they're not, which makes it what type of graph? B, state what we can conclude from the graph. So we've got the self-reported improvement score following 6 weeks of therapy intervention, and we've got the type of therapy. We've got CBT, so that's types of therapy, cognitive behavioral therapy, antidepressants, which is medication, CBT and antidepressants. We've got yellow, which is the control group, and we've got self-help group, and we've got improvement scores. Okay, which one improved? We see CBT improved, antidepressants improved a little bit more. A combination of CBT and antidepressants improved greatly. The control group didn't improve at all, and only one person was improved with the self-help group. So what we can find is the most effective therapy for dealing with, I'm assuming it's depression because they're being dealt antidepressants, would be CBT and antidepressants together. Okay, identify the type of graph. Here we've got average exam results in a maths and science by gender. So we can see the boys on the left, the girls on the right, the maths is in blue and the science is in orange with a score out of 80. Identify the type of graph. What type of graph is that? Let's find out. B, state what we can conclude from the graph. There may be more than one conclusion to be drawn. So if you have a look, we can see The boys did slightly better in maths than in science, but it was quite similar. The girls did did better in maths than they did in science, more drastically. You can see they got higher grades. In comparison between boys and girls, you can see girls did better in maths than the boys did, but the girls and boys did relatively similar in science together. And the last one, identify the type of graph. What can we conclude from the graph that have been there may be more than one conclusion. So here, what type of graph is that? We've got the relationship between self-reported stress score and total week sleep. And we can see hours of sleep per week and stress score where 10 is the highest. What can we conclude from that? Well, we can see that it's a downward trend, so we can conclude that there is an association between the hours of sleep per week and stress and a stress score. The higher the hours of sleep, the lower the stress score, or the lower the stress score, the more sleep, or vice versa. Right, so let's have a look. For each of the following, what is this? That is a scattergram or a scatter graph. And B, there is a positive correlation between the scores on a general knowledge test and age. Positive correlation, right? There's a positive correlation, not an association, correlation. B, that is a bar chart. The most effective therapy is CBT combined with antidepressants. All of the therapies are better than none. Any other reasonable conclusion from the graph? Yeah, so essentially anything is better than the control, which is essentially no treatment. B, again, we got bar charts. On average, girls outperform boys on the maths. Boys and girls scored equally well on the science exam. Both boys and girls do better on maths than science. Exactly what we said. And then the final one, this is a scattergram. There is a negative correlation between self-reported stress scores and the number of hours slept per week people report, suggesting that people who are more stressed sleep less. But we can't come to that conclusion. We know that there's a relationship. And that's the presentation and display of quantitative data. We had a look at different types of graphs. We use graphs in everyday life. Where do you look at graphs? Where would it be useful in real life to use graphs? Okay, and what questions have you still got? If you're wondering anything, let me know. I'm here to help. Right, and that's learning objective 1 complete. Show comprehension and apply knowledge of presentation and display of quantitative data. Now we're going to look at identifying and analyzing distributions. We've got normal distribution. So those that do maths, this should be familiar to you. You have a normal distribution. If you measure certain variables, such as the height of all the people in your school, or the frequency of these measurements, should form a bell shape. This is called a normal distribution, which is symmetrical. So we can see that the mean, median, and mode of a normal distribution is all in the same place. Okay, if we were to get height, the average height might be around, let's say, 5'10". And you can see the majority of people. So if we took everyone's height and divided it by the amount of people there were, that should be exactly where the mean. That would be the mean. The median would be if we put everyone from the shortest to tallest and we went to the middle person, that should be the person should be 5'10", and the mode is the most often. The majority of people will be around 5'10". There'll be a few people slightly shorter, around 5'8", 5'9", a few people slightly taller, 5'11", 5'12", and on either side, the more extreme you go, the less people there are. So for example, there's a lot less people that are going to be 4 foot, and there's a lot less people that are going to be 8 foot or something like that. Normal distribution. Within a normal distribution, most people are located in the middle area of the curve, with very few people at the extreme ends. The mean, median, and mode all occupy the same middle point of the curve, okay? If you've got this normal distribution, it's symmetrical, or around symmetrical. And the mean, median, mode all occupy the same midpoint of the curve. The tails of the curve, which extend outwards, never touch the horizontal x-axis and therefore never reach 0, as more extreme scores are always theoretically possible. But you've also got skewed distribution. You've got normal distribution, but there's also skewed distribution, where they're not all in the same place. Not all distributions form such a balanced symmetrical pattern. Some data sets derived from psychological scales or measurements may provide skewed distributions. That is, distributions that appear to lean to one side or the other. Okay, they can be skewed to the left or they can be skewed to the right. A positive skew is where most of the distribution is concentrated towards the left of the graph, resulting in a long tail on the right. Imagine a very difficult test in which most people got low scores with only a handful of students on the higher end. This would produce a positive skew. So you can see from the image here, this is positively skewed. You can see the majority of people are going to be on the left of the majority of people are going to be towards the end. They're going to be towards the left where they got really low scores, and only a few people are towards the right, which is the high scores. It is interesting to note, how the various measures of central tendency are affected by this situation. The mode, as we would expect, remains at the highest point of the peak because that's the most often, right? The most people, most often mode, the most frequent is going to be the people at the top of the top of the distribution curve, of course, because that's what it is. The median comes next, but the mean has been dragged across to the right. Remember how extreme scores affect the mean. Here, the very high scoring candidates in the test have had the effect of pulling the mean to the right, whereas the median and the mode, neither of which include all of the scores that are, when they are calculated, remain less affected by this. The opposite occurs in a negative skew. So we can see from the graph a negative skew. A very easy test would produce a distribution where the bulk of the scores are concentrated on the right, resulting in a long tail of an anomalous curve scores on the left. The mean is pulled to the left this time due to the lower scores who are in the minority, with the mode dissecting the highest peak and the median in the middle. Question. There are certain statistical facts in relation to the normal distribution and the standard deviation. As can be seen from the graph, 68.26% of the population fall between one standard deviation above and one standard deviation below the mean value, the middle section of the curve. Okay? And that's in every case. So if you work out the standard deviation, one standard deviation above and one standard deviation below is going to be 68.26%. Two standard deviations above and below the mean includes 95.44% of the population, which means there's just below 4% outside two standard deviations. And 99.73% are three standard deviations above and below the mean. So we can see less than 1%, a lot less than 1%, around 0.27 is above or below three standard deviations. Question. It's a simple question. Using the graph, work out what percentage of the population would be between the mean and one standard deviation below average. Note that the answer is the same in the case of one standard deviation above average. Can you work it out? If it's 68.26% above and below the standard deviation, what's it going to be from the mean to either -1 or from the mean to 1? It's going to be half of that. The percentage of the population that would be located from one standard deviation below or above the mean is 34.13%. So it could be there, right? Between 0 and 1 or between -1 and 0 is going to be 34.13, half of 68.26. Easy. There we go. For each of the 3 graphs, state the name of the distribution and explain its characteristics. On the left, that is a normal distribution, where data is normally distributed. Most people's scores will be located centrally around the mean, mode, and median. This one is negatively skewed, where most scores fall the low side of the curve. And this is a positive skew, where most scores fall on the high side of the curve. And that's distributions, right? Some of them are normally distributed, some of them are skewed to the left, some are skewed to the right, and that's all you need to know. So I'm ticking off identify and analyze distributions. We're moving on to our plenary. Let's do these multiple choice questions and we are done. Number 1, which would be most suitable for displaying a correlation? Remember, correlation. Okay, interesting. A line graph. B, a bar chart. C, a histogram. D, a scattergram. It is D, a scattergraph or a scattergram. Number 2, what percentage of the population fall within 1 standard deviation above and below the mean on a normal distribution? 6.8%, 68.26%, 3.4%, or 34.13%. As we just knew, it's above and below the mean, which means it's 68.26%. Number 3, a very easy test would be likely to produce what? A normal distribution, B, a positive skew, C, a negative skew, or D, a curvilinear relationship. It's not normal. It's going to be positive or negative. Which one are you going for? Negative skew. Good. Well done. Because they're going to be towards the left. 4. Which is not a feature of a normal distribution? A. The mean, median, and mode are all at the same point. No. B. Most scores are located in the middle of the curve. No, that's true. C. The extreme ends of the curve never touch the x-axis. Okay. And D. The graph demonstrates positive correlation. No, it's not D. It's nothing to do with correlation. And there we go. If you have any difficulties, please press the link for the video there. What is skewness? So watch the following video for further support. Otherwise, ask me if you've got any questions. Let me know. How many did you get out of 4? Are you an absolute legend and got 4 out of 4? Maybe you are. Maybe you're not. Probably not. No. You're all smart. You all did well. And there we go. That was today's lesson. Lesson 26 was graphs. Well done. Thank you for joining today's lesson. Today, be sure to submit your notes on the classroom. Well done, my neo-psychologists. Keep up the good work. Next lesson, we're doing lesson 27, mathematical content. Stay safe. Peace.
I'm feeling like Will. I feel like a prince. I'm feeling myself. I'm loaded with bills. Cause I wasn't blessed with no Uncle Phil. Don't know how it feels. I wanted to flex. They told me to chill. I'm making a flip. My life is a flick. Now load up the film.